Computer vision in traffic management is something that's being used a lot these days, and it has high impact in terms of regulating the flow of traffic and making sure that your commute times stay to the minimum. Welcome back to the channel, guys. My name is Dhruv, and at Convolve, we assist with solving your problems with computer vision and AI. Oftentimes, while driving around, you may see these kind of cameras mounted on top of the intersections. These cameras are becoming more and more common. These cameras are used for traffic monitoring. Now, given that a camera is recording the feed of a traffic, you know that there's a lot that can be done when you have the data, when you have the RGB stream coming from a camera using computer vision techniques in today's era. These cameras are already being used by municipalities to better understand the flow of traffic, to monitor the traffic, and to adaptively give commuters heads up with regards to travel times and to let them know of any blockages if there are any. Now guys, with the modern AI and computer vision, there is a lot more that can be done in order to ensure that we can better manage traffic, we can better direct traffic, and we can make the flow of traffic smoother on our city streets and also on the freeways. One of the application that comes to mind is smarter traffic intersections. This means traffic signals that are adaptive and that are able to adjust to the traffic needs, the traffic demands. One of the examples could be by understanding the number of cars, number of vehicles that are traveling through the intersection in all four directions. Better management can be done with regards to how long a signal turns green on one side versus the other side. As an example, if say the traffic flow is very high in one direction, so if you have an intersection with one road and the other road, if in this road the traffic flow is high, then the traffic lights can be timed accordingly as compared to the other road. In this video, we'll show you guys an example with regards to the left turn signals, especially with regards to advanced left turn signals. Now guys, on the screen you can see an advanced left turn signals. This is very common, especially in busy streets on busy intersections. Oftentimes you would see an advanced left turn signal. For those of you who don't know, if you are on a normal signal and you want to turn left, the light will turn green. You have to go into the intersection and then you have to wait while the oncoming traffic clears out, and then you can make the left turn whenever it's safe to do so. With an advanced left turn, you don't need to wait for the oncoming traffic. It's solely for the person who wants to turn left. You have an advanced left turn signal, you can just turn left. Now in certain cases, if there are, say for example, too many cars that need to turn left, it's possible that the left turn lane gets jammed up and that jam continues on to the main forward going lane, and that ends up jamming the traffic for the entire of that lane, and it causes traffic slowdown, traffic jams, etc. Now, if the camera at the intersection is able to understand the number of vehicles that are trying to turn left, that way the left turn signal can adaptively be changed and the timer for that can be adjusted so as to allow the majority of the vehicles that want to turn left in order to clear the traffic backlogs, in order to clear the slowdowns, and in order to avoid any sort of traffic jams. Now guys, here on the screen you can see a sample data from a traffic intersection. This comes from a live webcam that is streaming live on YouTube. So we take a clip from here. This is an intersection where you have a left turn lane and then you have the normal lanes. Now guys, the objective here is to understand the number of vehicles in the left turn lane at any given point. For this, we utilize an object detection model that is based on the YOLO model. And the idea is to first figure out and calibrate the camera with regards to where the left turning lane is. And then from there, detect every car that appears in that particular lane and have a counter that counts and tracks the number of cars that are in that particular lane. And finally, that's further information is used to time the left turn signal. Now guys, let's start with step one, which is to first calibrate the camera to tell it where the left turning lane is. Now, once you have a camera installed at an intersection, you can do it during the setup phase. For whatever task you have, you can do that calibration and you can have that data handy for the further downstream tasks. For this, we use a simple OpenCV based library that takes some mouse callback. So we open the image. On the image, we select 4 different dots, and these are the 4 dots that define a trapezoid that essentially defines the left turning lane. Now guys, once we have that left turning lane figured out in terms of the camera, the next step, which is step number 2, is run an object detection model. Now for this, we use YOLO V8 model, and the YOLO V8 model is run on the stream of data, and its job is to detect vehicles, cars, trucks, vans, etc. The YOLO V8 model detects the vehicles, and the vehicles that fall within the area of that left turning lane are flagged as the vehicles that are turning left, and we have an active counter which keeps the count of the number of cars in that left turning lane. So here on the screen you can see a demo for it. You can see a trapezoid for that left lane, and any car that comes into that lane gets a bounding box around it, and on the top left hand you see a number. This is the active count being displayed for that particular instance. So at that particular instance, the number of cars in the left lane are depicted over there. Now guys, with such a system in place, further information about the number of cars in that left lane can be used, such as to uh, adaptively change the timer for your left turn signal. If there is a huge backlog, the left turn signal can be turned on for a longer time, whereas if the number of cars as we see in this video is 1 or 2, then it would just be the normal standard set time and nothing needs to be changed. Again, this is not possible with simple operator monitoring because there's too many intersections. That's where computer vision and AI can assist, wherein with these methods we can adaptively vary and we can adaptively manage traffic on the go. So guys, this was one of the example demo for traffic management. There's a lot of stuff that can be done. If you are interested in the code for this demo, or you want to know how this was implemented, please leave a comment and I would be happy to go over it, or I would be happy to post the code on GitHub. I hope governments, I hope municipalities continue using more and more computer vision based techniques on their roads. This will make the roads safer and also reduce any issues with traffic. It would ease commute time, and it would also make the commuter's life so much easier and stress-free. Thanks a lot for watching, guys. If you are interested in having a chat about your particular problem, or if you are working for the government, or if you're working in a municipality and you're interested in having further conversations about these traffic management techniques, here is our contact information. Feel free to contact us. I would be happy to help you. We would be happy to chat with you, and we would be happy to understand your problem. Thanks a lot for watching, guys. If you like this video, please hit the like button, subscribe to the channel, and hit the bell icon so you are notified about any new video that we upload. Again, thanks for tuning in, and I'll see you in the next video.